Okay, so looking at the equation of the line is what we were talking about at the end of last unit. So we're talking about things like y equals mx plus b. I know it's already written there, but I'm going to write it nice and big. This is called slope-intercept form because what it does is it shows us the slope, which is m, and remember, slope is the rise over the run. The rise is how much it goes up, the run is how much it goes to the right. Now the y is just a y value of some point. So we can find a point on that line. The x is the x value of that point. Now most of the time we don't know what those are, so we just leave y and x as variables. But the b value, that's the intercept. That's the y-intercept. So this is where the line crosses the y-axis. Where it crosses the y-axis. Okay, so if I said to graph these points, we're always going to do it the same way. Okay, so we're going to make sure it's in y equals mx plus b. Which all three of these are. The first thing we're going to do is we're going to put the y-intercept on the graph. And then we're going to use the slope to find two more points. So we should always be graphing at least 3 points. There are some instances you can't, but we always should try. So in this case, our slope for the first one, our slope is equal to 3 over 4, and our y-intercept, the b value, is -2. So what we're going to do is we're going to go to -2 on the y-axis. It's crossing the y, and then we're going to go up 3 over 4. There's 1 point, up 3 over 4, there's 2 points. Now remember, if you run out of space, you can do the complete opposite. You could go down 3 over 4 the other way, down 3 over 4 the other way. Okay, and now you're going to connect the line, and you're going to put an arrow at each end because this line goes on forever in that same pattern. Okay, so let's look at the next one. The next one, again, we've got our slope. Our slope in this case is -1 over 2. Now that negative, we're always going to put it up to the top, okay? It doesn't actually matter because if you put it on the bottom, you'd be moving left. But to make it constant in the same thing over and over again, we're going to put it over on the top. So now we need to go to 4, put a dot. Now if I look at my slope, it says down 1, right 2. Down 1, right 2, and I can kind of do this forever if I really want to. Or we can go up 2, or down, sorry, up 1 and left 2, and look at all those dots I've got. Okay, the more dots you put, the more accurate your line's going to be. I need you to have at least 3 dots. Okay, now this last one, we've got our slope. It's going to be -2, and remember, any number we can put it over 1. Okay, and a lot of the times writing the slope as a fraction makes things easier. Our b value is 1. So what that means is I'm going to go to 1 on the graph, and then I'm going to be going down 2, right 1, down 2, right 1, down 2, right 1, and so on. Okay, I'm going to do a bunch of them, or I could go up 2 and left 1, up 2, left 1, and look at all those dots again. Then when I connect the dots, it's a nice straight line, and I can put arrows on the end. Again, you need to have at least 3 dots. Horizontal lines. Now, we talked about this a little bit in class already. If I have y equals 3, remember, horizontal line has a slope of 0. So if we had y equals mx plus b, our slope is equal to 0, And 0 times any x value is still going to be 0. So that part of the equation actually goes away. So we just have y equals b, which is the y-intercept. So we can put our y-intercept on there, and we can then just connect all of those dots. Okay, so it's not going to actually change anything if we connect the dots, or if we just draw a line on top of the y-intercept. Okay, now we can look at the second one. We've got -2, same thing, and it's right there. Okay, what we'll do is we'll make this one a dashed, whoa, why don't I just change the color here? We'll make the second one, I don't know, red. So this one is red. We're just gonna do that. There we go. All right, now the same thing's gonna happen with vertical lines. Now vertical lines, remember our slope in this case is undefined. So if we were going through and trying to do a slope, we actually couldn't. But if we've got our vertical line, it's the same process as the horizontal line, except it's obviously vertical. Okay, so you're just finding whatever it's equal to, drawing it up and down. Okay, so remember, vertical line has an undefined slope. A horizontal line has a slope of 0. Finally, if we have an equation like this, or it says identify the slope, what does it represent? Okay, so here we're going down 1, right 1. Remember, slope is rise over run. So our slope is -1 over 1. And it represents, we actually have to look at the equation. We have a kite flying over the ground. So this is the kite falls 1 meter per minute, or goes down, or is descending, however you want to put it. State the y-intercept. Okay, well the y-intercept is up in the corner there. The y-intercept is going to be 10 right at the start. So our b value is 10, and it's the kite's initial height. And then finally state the equation. Well, we've already got the slope. We know it's y equals mx plus b. So we would have -1 over 1, or -1. And you actually don't have to put that if it's a negative. You could just write -x plus 10. Now, the final thing says, what is the x-intercept? Well, the x-intercept is just where it crosses the x-axis. And our x-intercept here is actually equal to 10 as well. And what this, dotted line, what this represents is the amount of time, because we're reading the question, the time it takes for the kite, the time it takes for the kite to reach the ground. And here are some questions for this.